Hello, my name is Michael Puchalski, and I'm a part of the Mechanical Engineering Senior Design Program, Team 1. We're working with our customer Android Industries and our advisor, Dr. Scott Mears, to create an automated tire and wheel demounting system. Our team members include James Daavettila, Matthew Kreft, Robert Gossen, Michael Puchalski, Caleb Sanders, and Ethan DenHartigh. Our customer Android is an OEM supplier of wheel and tire assemblies, also called combos. In their manufacturing facility, they take the tire and the wheel, assemble them, and then inflate, balance, and test each tire before putting them directly onto a truck. These completed tire and wheel assemblies are then shipped directly to the Big Three and mounted onto a vehicle in production that day. Throughout Android's production process, they run a numerous amount of tests, checking if the tires are balanced, if they roll uniformly, and so on. If a tire fails any of these tests, it is then rerouted to the demounting area. The tire and wheel assembly is demounted and then sent back into the system. Most of these failures can be fixed by pairing a different wheel with a different tire, so they try to reuse the tires and wheels as much as they can. In the demount area, Android uses machines as seen here on the left, typical tire changing machines that you would see in your local tire shops. Using these machines in a high production environment can cause damage to the wheel and tire and broken sensors within the tires. These machines can also cause a lot of operator strain. The purpose of our project is to eliminate these over-equipped machines with a system that demounts tires and eliminates the possibility of human injury and quality issues. Our solution consists of 4 main components: a clamp, an upper bead roller, a lower bead roller, and a hook. These 4 components work with an industrial robot to provide all the functions necessary to demount a tire from a wheel. The lower bead roller is used to break the first bead of the tire off of its seat on the rim. The upper bead roller serves the same purpose, but to break the bead on the opposite side. The hook is used to pull the first bead up over the edge of the wheel, and then we move back to the upper bead roller to push the final bead off of the wheel. The clamp is used to connect the tire and wheel assembly to the robot. It passes through the center board of the wheel, then uses a pneumatic cylinder to pull a set of 4 links down like a cone to hold the wheel and tire in place. Now we'll take a look at a simulation video of our process. So the defective combos would enter on an entrance conveyor. The clamp would pick up the combo and move over to the lower bead roller where the first bead is broken. Can then move over to the upper bead roller to break the bead on the second side. After both beads are broken, it can move over to the hook where it inserts itself underneath the bead of the tire and pulls that first bead up over the edge of the wheel. And finally, move back to the upper bead roller where the final bead is pushed off of the wheel. The tire would then fall onto the tire exit conveyor, and the wheel would be placed on the wheel exit conveyor. The tire and wheel would then be cycled back into the system to be paired up with a different tire and wheel, and this process could repeat. This solution will reduce operator strain and injury, decrease the cycle time in the demount area, and limit the damage on the wheels due to the manual demount process. Our next steps are to perform testing with an industrial robot. Our team would like to give a special thanks to the following: Android Industries, our customer, Jim Crom and Tim Dino, our advisor, Dr. Scott Mears, the 6th Floor Machine Shop, Jeremy Esch, Cleveland Cliffs, the MET Machine Shop, Great Lakes Sound and Vibration, APS Labs, and the Q&R Research Center.